The software is able to derive pipe long section elevations from two sources. One, from survey long section drawings or engineering isometric drawings that the user manually interprets and manually enters their data. Or two, background contours. Pipes along routes in the case study have their pipe obvert profile between nodes automatically defined by the ground contours and each pipe's pipe laying condition. Similarly, at a pipe's end nodes, the ground level data for the node is used to calculate the pipe's obvert level at the ends of the pipe. Your mission is to understand how to use two data items to control calculation of pipe obvert levels along a pipe. The first piece of data is found at the Options Job Settings menu. Under the Pipe Limits tab. Note this value, cover above obvert of buried pipes. Similarly, for above ground pipes laid on support blocks, there is this value, clearance below invert of above ground pipes. These two values can be applied globally to relevant pipes in the model. How do we know which are relevant pipes? The answer is individual pipes with a pipe laying condition specified as buried at cover, lying on the surface, or above ground on blocks. Cancelling that form because they are the case study's standard values. The second piece of data is the pipe laying conditions specified for individual pipes. Let's explore that by looking at one of the new pipes you added to the model, namely section 3 near the start of the pumping main. Right-clicking it and selecting Edit. Note its pipe laying condition has been set as buried at cover, being the default value given to all new pipes when they are added. Expanding this menu option, here are the other choices. Note these three cases can be computed from ground contour levels. These two cases cannot. Selecting them requires the user to manually define how the pipe elevation changes along its length. Cancelling that form. In the case study, the vertical profile for all except one pipe in this model is automatically defined because each pipe is given the pipe laying condition buried at cover, making the pipe obvert 0.7 meters below the ground level. The convenience of the approach, using two simple pieces of data, is demonstrated by selecting route operations from the side toolbar, selecting Show Route Profile, and pointing to a route, and turning some helpful data on. Here we can see the land and pipeline vertical profile based on the underlying contours. Exiting from the profile, exiting from route operations. Now we are going to look at that one pipe where its vertical profile needs to be manually entered because its pipe laying condition is follows plant isometrics. In edit mode, find the pipe labelled station out. Clicking on the pipe, selecting the edit menu just to demonstrate that yes, its pipe laying condition is follows plant isometrics. Cancelling that form, selecting the pipe again and this time selecting the vertical profile menu. This form allows users to enter pairs of distance and elevation values in the new fields. Users can also tick is vertically above or below the prior bend or node to add a bend at the same map coordinates as its upstream neighbour. Each time the mouse cursor moves back into the new distance field, entries are written into the pipe's profile table and the new fields are emptied ready for a new set of values. Let me demonstrate by adding the 4 values shown in the workbook. Users can delete a row from the pipes profile table, clicking anywhere in that row and pressing the delete button. To modify distance and elevation values already in a pipes profile table, users can type directly into cells in the table. To remove the vertical elevation value from a bend and retain the bend in plan view, users erase, that is backspace or delete, the value from the elevation cell in the table. Clicking the OK button and the Save button.